Now, as this, what is the relationship between mk and mk plus 1?
K plus 1 less होना चाहिए सुप्रीम
So this is because okay. And L is the limit of all these. So what would be the relationship between L and MKs? Of MKs. This must be less than or equal to L for all. So this is true for all k bigger than or equal to L. This is true for all actually. This thing. So it's like if you are saying that this sequence is decreasing and going below, so it must converge to infimum. So infimum of all these numbers. That infimum must be smaller than or equal to each of the terms. Infimum equals की हर term से बड़ा. So that's what we are saying actually. See? That's what we are saying. यदि अगर इनमें से हर एक से बड़ा है ठीक है we agree with this situation in particular. It's just trickier computations. In particular, I can say that this L is less than or equal to M1 actually. होगा less than M1 से होना चाहिए. Less than or equal to M1. And M1 is what is the supremum. Supremum of what? A1, A2, and so forth. Okay. Now consider this number M1 minus epsilon. Consider this point M1 minus epsilon. Why this is an interesting point? Why this is an interesting point?
In case I add
Don't they get okay, something smaller than epsilon, so there exists. So there exists M1 as that. So that
M1 minus N1.
such that we can say that A1 is bigger than or M1 minus epsilon is less than what? ठीक है? Similarly, I can say if this L is not only less than M1 but it is also less than or equal to, it's going to be also less than or equal to Mn1. This range X का is going to be also true. So I'm going to say that so there exists M2 which is going to be after M1 for which we can say that L or maybe M N1 minus epsilon okay is less than Again, now you can see actually that we don't have a continuity. So I'm not saying that. So it's like this. So this N1 is not N2 or basically 2 after. It could be so it could be M3, M5, M10. Okay. You can already see that maybe there are some points are being missed at. Therefore, this. So we got that. And so if I continue on doing this, okay, I would say that for N1 smaller than N2, so it's like there exists N1 smaller than N2, smaller than N3, and so on and so forth, such that, okay, such that K such that M and K minus epsilon is smaller than Kn. We got that. Let's see that this is what that we want to have. Now just think about it. So what we are saying that M and K minus epsilon is bigger than A and K, but this guy is less than or equal to something. That something is
A and minus A.
How can I be sure actually that? Do we have this surety?
We are looking at
Surety from here. We have surety from here. So in other words, we have surety from here. We are saying that L is less than or equal to all of these MK. So I can say that this is going to be smaller than L minus epsilon, which is bigger than or equal to. Say that it implies that A and K minus. So it's like bringing this quantity there. Huh? That's what I wanted to basically go for. That from this I can conclude that A and K is bigger than
L minus L.
bigger and lesser. Bigger?
वहाँ पे bigger है, दोनों bigger होंगे, ऐसा होगा.
I should write this L minus R.
ऊपर वाले में दोबारा
यहाँ गया है
ऐसा इधर हो, उल्टी कर दो.
हाँ ठीक है
और इसको भी
उलट दो. Now it takes sense. So I can say that A and K minus epsilon is bigger than and K minus L is bigger than epsilon for NK basically. But these NKs are what? So these NKs are N1 bigger than N2 bigger than N3. So these are infinity NK for which this quantity is. And that's what we want. Minus epsilon obviously. That's what we wanted to show. Okay. So boring proof. Okay. It just follows from definitions and some simple tricks. Okay. Try to make sense of this proof. And once I have this, so precisely on the same lines you can argue about it. Precisely on the same lines you can argue about. Now, using this result, so if I say that what's a summary of this result, the summary of this result is that if I have a sequence and its lim suit, which is L, then the difference between the sequence and L, this lim sup is going to be less than or equal to epsilon for all of it bigger than or equal to N1. That is going to be bigger than minus epsilon, not for all but for infinity value. And similarly, you have to do this about the left. Just think about it for yourself. This is going to be precisely on the same line. But now we will have a payoff of this result. We'll have a payoff of this result. I hope that all have noted it down. Get rid of it. And this result is that if a sequence is convergent, then there are limits and then say. Okay. So for any sequence, like for an, we have. So that's limit n goes to infinity of an is L if and only if lim sup n goes to infinity of an is equal to lim inf of n goes to infinity an, that's equal to n. That's equal. Because if a sequence is convergent, then we can make sense of it easily. Just think about it. That I have a sequence, like I have a sequence that wanders around, but after some time we'll get nearer and nearer.
Means square the definition is different here.
Yes, we can correct right there. Okay, if you compute lim sup and lim n for a sequence, and if both are same, then that will be the limit. And we actually saw that it's much easier to compute lim sup and lim n. Tricks dealing with the sequence. So let's assume this part. Okay. Let's do this part. Assume that the limit is basically this. So as an goes to L, okay, and for n goes to infinity, for n goes to infinity. So for the given epsilon positive, we're going to say that there exists number n such that the relationship between, the distance between A and L is less than epsilon for all n bigger than or equal to n. So that's what the hypothesis is given. So like to prove is basically So we assume this and then we like to calculate this. Now consider the capital M corresponding to this N. In other words, this M capital. In other words, something that existed. So what would be this? This is going to be the supremum. Supremum of what?
In capital.
Going to be N plus 1, so on and so forth. So what we can say immediately about this Mn, equal to 1.
सबसे बड़ा opportunity है.
I say that this must be bigger than L minus epsilon and less than or equal to L plus epsilon. Why this would be the case? Just think about it. This inequality holds for all ALs, for all n bigger than or equal to S. So it's going to be true for the supremum as well. It's going to be the supremum as well. But it's not necessary that it should be a particular number from An. Now you can say that why this Mn can be L plus epsilon, but why you have equality and why you don't have equality. Just think about this point.
It can be among these sections, among this set.
What will be the trouble if Mn is equal to L minus epsilon? Exactly. So if the Mn is equal to L, then this Mn will not be a supremum actually. So therefore, you can't have equality. Okay. But this supremum would be L plus something. It can go beyond this. Is it making sense? So why this should be, why you have a strictness here and why you don't have a strictness there. ठीक है? कुछ समझ आ रही है? सो है Who's stuck? Either Walid is stuck. Walid?
Sir, I'm not stuck.
So we are saying that, An minus L is less than epsilon. So it's like An is smaller than L minus epsilon for all n bigger than or equal to that. So you're going to say that the supremum is also going to satisfy that condition. Why? Why this should be the case? If you want to see it explicitly, An is bigger than or An is less than what L plus epsilon. Okay? So it's like that's what it says for all n bigger than or equal to N. Okay. Now this means that this is an upper bound for this scalar. So if I take the supremum of these ANs like this, then this supremum can be equal to this upper bound or can be less than this upper bound. Because the supremum is least upper bound. But this An is bigger than L minus epsilon, which is for sure. Then the supremum is also going to be bigger than L minus epsilon, because if the supremum is equal to L minus epsilon, then there will no more be a supremum. That's something. We are assuming too much. are getting committed. If you have very good questions, you ask me. You ask. So you need to be active. You can't be passive here while moving things. You have to keep your facts in hand actually. Thus I would say that this sequence mk, where k bigger than or equal to l, like all those mk's forward, which are after this mn, from mn to n basically, after it, is a bounded sequence. It's like a bounded monotone sequence. Agree with it? Bounded monotone sequence. So it's a bounded monotone sequence. Okay. If it is a bounded monotone sequence, then I have a claim actually. And that claim is that their limit n approaches to infinity of these mn's, which is basically lim swoosh, okay, of an, just writing it for the sake of convenience, is bigger than or equal to L minus epsilon, something in sync, but less than or equal to L plus epsilon. Why this is the case? Why this is the case? So that's why we are saying that as the Mn is between L minus epsilon and L plus epsilon, and Mk, so it's like so Mn plus 1, Mn plus 2 is a bounded monotone sequence, that decreasing sequence. So it must converges to its infimum. And we are saying that that infimum is also going to be between basically these two numbers. But why this should be the case? Just think about it. If the Mn is between these two numbers, okay, this Mn must be bigger than or equal to the infimum of these numbers basically. So how come that number which is infimum, smaller than this, cannot be between this interval? So it should be between this interval.
And since it's infimum, so it can be equal to L minus epsilon.
Exactly. So therefore it could be equal to L minus epsilon. Is it making sense? So it's like this number Mn. I mean, if we understood, if we are convinced that yes, this must be between L minus epsilon and L plus epsilon, is a term in this sequence. Okay, and the lim sup is the infimum of this sequence. So if the lim sup is infimum of this sequence, then every single term in this sequence must be bigger than or equal to that infimum. Okay, including Mn. So I'm saying that Mn is bigger than infimum and Mn is between these two numbers. I don't see any reason that why this smaller number should not be between.
So equality is almost like different.
Yeah, so in other words, inequality तो यहाँ ही basically. Imagine that कि the infimum यही बताते खुद हो number. You can have possibilities. हो सकता है ना कि you have a constant sequence and Mn बताते खुद infimum हो. So you can have it equality. But think about that. Why this should be basically equality here? Huh?
इसलिए दे रहे हैं कि सुप्रीमम नहीं लेते.
So जैसे हम यहाँ कह रहे थे कि this supremum must be bigger than L minus epsilon, but it can equal to L plus epsilon. So this infimum, can equal to L minus epsilon, but it should be strictly less than L plus epsilon. But here we still have equality because this infimum can be Mn itself actually. That's a bit different condition from above. Okay? फिर से यहाँ से समझे? Let's start from here. ठीक है? So what we like to prove is that imagine a sequence is converging to a limit L, then their lim sup and lim n first be L. That's what we want to do. So assume that the lim sup is, assume that an is L actually. Okay, so an is L. So if the an is L, then for every epsilon positive you can find n, such that an minus L is smaller than epsilon. Whenever n goes beyond basically this n. So this means that my an should be between L minus epsilon and L plus epsilon. L plus epsilon and L minus epsilon for all n bigger than or equal to. Agree? Okay. So I'm saying that let's take the Mn, which is the supremum of all these terms basically. Okay. So my claim was that this Mn should be also between L minus epsilon and L plus epsilon. Okay. So it could equal to L plus epsilon, because it is supremum and this is an upper bound. So why I'm saying that Mn should be between L minus epsilon and L plus epsilon? The reason is very simple. Better if I have Mn, so it's like I can treat this L plus epsilon as an upper bound, basically for all these numbers. Okay, and supremum is also an upper bound for all these numbers. So what should be the relationship between this supremum and L plus epsilon? It should be less than or equal, because this Mn is the least upper bound. It could be L plus epsilon. I don't know that whether this is supremum, but it could be strictly less than L. Okay. But this Mn cannot equal to L minus epsilon. Why? Because if it is equal to L minus epsilon, now this will no more be a supremum. Okay, so this is equality. Then I'm saying that this Mn, so since this sequence Mn plus 1, Mn plus 2 is a decreasing sequence. Okay? So it must converge. So it must converge to what? Infimum. Okay? So it must converge to infimum. Let me write this fact explicitly so that it can make sense. Okay? So it's like I have this Mn converges to what? Infimum of Mn plus 1 and so on and so forth. Okay? That's what it does. Now what should be the relationship between this infimum and this Mn? We're going to say that this infimum is going to be always smaller than or equal to each of these Mn's. Agree? Okay? Each of these Mn. So we are saying that if the Mn is between L minus epsilon and L plus epsilon, so the number which is smaller than this, how it cannot be between L minus epsilon and L plus epsilon? So it must be between L minus epsilon and L plus epsilon, which is basically this inferior. Okay? And we can say that there, yes, this can be equal to L minus epsilon because it is inferior. Because kind of this is, okay, because this is the lower bound basically. So this is lower bound for all these Mn's. So if it is lower bound, the infimum is also a lower bound, but that's the greatest lower bound. So this must be bigger than or equal to what L minus epsilon. Does it make sense? Right. So what we just proved actually, that the distance between lim sup and L is less than epsilon. Okay. Are you getting the point? For all n bigger than or equal to what? So that's what we wanted to prove. So we proved basically that okay, the limit of this is going to be L. Okay. Think about limit for yourself. कहाँ पर बेटा? हमें चाहिए strictly less. चलिए ऐसा कर देते हैं, ऐसा कर देते हैं. Let's play again. That's a good question, beta. It's a very good question. We need strictly less than epsilon. Let's take epsilon by 2 here. So you're gonna have epsilon by 2 here, and epsilon by 2, and epsilon by 2 here. So now you have